Hi. One of the most important debates you may be hearing about the development of generative AI is whether it should be developed by closed source companies such as Google, OpenAI, etc., or whether it should actually be open source, where open source means essentially that it is open out to anyone, any company which has the technical capability and is able to develop these models. Why is this important? This is important because it determines whether the future development of generative models, which are becoming increasingly very, very important and advanced, is in the hands of a few key companies or is spread across the internet and across a very diverse group of companies. The issues are complex, however, and there is no clear answer. There are actually pros and cons associated with both sides. In this sequence of videos, I'm going to start with the basics of defining what is an open source model and go on, and then subsequently, once we understand that, because there are complexities there as well, we will be then talking about what are the various issues associated with open source versus closed source models. This is the first video in this sequence and is associated with the definition of open versus closed source models. Hi, this is Shelly and this is my YouTube channel AI Economics. I take complex topics in the area of artificial intelligence and decode them for their management and business impact in simple terms. If you like this content, please consider subscribing to my channel and also hit the like button for this video. Let's move on now to open source models definitions. So let's get to understanding what is open source versus closed source. Let's take a simple analogy. Imagine a cake. In the open source world, the recipe for this cake, which is basically your code, is available for everyone. You can see the ingredients, the steps involved, and even modify it and add on new ingredients and sort of evolve the recipe if you like. So that's basically open source. In the closed source world, you can basically buy the cake and you can eat it. However, the recipe is a secret, or at least it's something which only the company knows. You can enjoy the cake, but you can't really modify it any further, and you can't understand or you have no clue how it was actually baked. Bringing this analogy back to the coding world, open source AI models are basically models whose source code, the architecture, and the pre-trained parameters are publicly available for anyone to use and modify and distribute. In the case of closed source AI models, the models are proprietary, and in that sense, their source code, architecture, and parameters are kept confidential by individuals and organizations. However, it's not as simple as that. Things are never so simple and black and white. There are wheels within wheels. So what are these wheels within wheels of open source definitions? So to understand that, we need to understand what are the components of a generative AI model. The first thing is the code. This is basically the computer program which kind of knits together all the elements which consist of a model and the language in which it's defined. This is usually written in a specific language such as Python, but can also be Java, etc. This defines the overall structure of the LLM. The second thing is the architecture. This is the blueprint that outlines how the different components or layers work together. The third thing is the training data. This is the massive data set of text and code on which the large LLM is trained. The quality and quantity of this data has a significant impact on the capabilities and performance of the model. The last thing is the model weights. These are the specific numerical values which have been developed as a result of the training and are associated between the connections between different layers in the LLM architecture. When we talk about an open source model, ideally we need all these four elements to be open sourced. However, typically the code and architecture define the overall structure, and the weights determine the specific behavior of the model. Typically, you will find that though at times the code and architecture is open sourced, a lot of companies do not necessarily release the training data or the model weights, which is what I meant by saying that the degree of open sourceness varies. Let's now talk about the degree of openness or open sourceness. So there are various shades over here. The first is fully open source models. That is, all the companies have open source the code, the architecture, the training data, and the weights. And everything is fully accessible to other companies or researchers and downloadable and modifiable. This is actually rather rare, and there are only a few models. An example of this is maybe Bloom, which is Hugging Face's large language model, T5, which is a Google model which has been open sourced, and I'm putting a question mark against this Databricks DBRX, which is the Databricks model, and which the claim is fully open sourced. However, I do need to go back and verify this. The second type of open sourceness is open source with restricted weights or other aspects. The instructions here are available, so you have the code, you have probably the architecture, but access to the full ingredient list, that is the model weights, might be limited. And there can be a variety of ways in which this can be limited. It can be a paid tier, you can have cloud access required, you may just be not given the training data set, for example, as is in the case of Llama 2. But most models such as Llama 2, Falcon 180 billion parameters, Jurassic Jumbo, and Gemma fall into this categories. This category of models. So they are kind of partially open source. And then lastly, you have open source for research, where some parts of the instructions or specific functionalities might be open for research, but full use is restricted. So we can say true open source requires sufficient material provided to fully understand, analyze, assess the properties such as safety and privacy of the software. So as you can see, to be able to do that requires you to have all the four components which I talked about. Even if one of these components is not provided, then the ability of a company to or another researcher to ultimately reproduce, modify, and extend a model's capabilities is limited. Rather than standing on the shoulders of someone, you will actually be trying to replicate, and in a slightly different way, rather than standing on the shoulders. Why is this important? By being able to independently reproduce a capability, one builds confidence in the ideas and engineering efforts behind the capability, and potentially you can build on it, which is the point I made about standing on the shoulders of giants. Without independent reproducibility, one must rely on a certain amount of one's own individual efforts, and this essentially means that the research is not reproducible, and therefore it limits its availability to open source. I hope you found this video engaging. This is part one, where I just talked about the definition of open source, and as you can see, there are quite a few complexities here. Follow me along with the remaining sequence of videos which I will be uploading shortly on the continued definition and usage of open source models. If you like this video, please hit the like button and also subscribe to my channel AI Economics, and hit the bell icon to be notified about new videos. So see you in the next video.